and welcome to the Scott Stirling Engine project.
Very nice.
My name is Ben Jones. I was the lead engineer on this design project. I worked with the first few initial designs that unfortunately were unsuccessful. I had my partners here help me to get to the final model.
I'm Cole Turner, flywheel specialist.
Okay, I'm Kyle Taylor. I was the materials engineer. I provided many of the materials and helped design the core part of this heat engine and provided many of the things necessary to get it running.
So a little bit more about how Mr. Scott Stirling here works. First off, we have our butane heat source, which provides the flame, which will heat up the air in the bottom can here. We can consider this to be a closed system made up of approximately 3 or 4 parts. The first part, which you actually can't see, is inside of this bottom can. We have a displacer made out of, what's it called? Floral foam. All of that goes up and connects into our crankshaft at the top, which also connects to our piston on the side and our flywheel here on the left made out of a CD and the parts of a Dr. Pepper can. So the basic process here is as we start with our displacer pulled up to the very top in this can, and we turn on our heat source, the air inside of here heats up to a reasonable temperature to create a temperature difference between the top and the bottom parts of the air, where the displacer is kind of a medium that between the two. As we start the actual flywheel in motion, the displacer gets forced down, which forces the hot air to move up around the displacer into our piston arrangement here, which consists of just a balloon. And as that hot air goes into the balloon, obviously with the hotter air, we're going to have a higher pressure, which will actually force the diaphragm of the balloon upwards, which will then, with these two crankshaft pieces being 90 degrees offset, as the displacer is down and the hot air goes up into our piston cylinder here, it's going to make the crankshaft go back up, thus creating a cycle of the displacer pulling down, pushing the hot air into the piston, where it pushes it back up, and the flywheel over here is used to keep the inertia going and keep it from being a little jumpy as the displacer gets yanked to the bottom under its own weight. And you can see when we get it started here in a second, after just giving it one slight push of the flywheel to get the momentum going, it is a completely self-sustaining system as long as it has a heat source. There you go.
That's perfect. As you're going to go.
All right, I'm ready when you are.
Maybe a little more heat. It's melting. Just having that